So a specific example of a step function that is commonly used as an example is the greatest integer function. So it's denoted over here, and it's y equals, and then you have the square brackets around x. So what this is telling us is that we're looking for the greatest integer that is less than or equal to x. So what it does is it takes in any input and will give you back an integer output depending on the integer that is the closest to x that is less than it. So for example, so f of 1, where f of x is equal to our bracket x, so it's our greatest integer function. So the greatest integer that is less than or equal to 1 is 1. The greatest integer that is less than or equal to 0 is 0. But the greatest integer that is less than or equal to 1.5 is 1. Because 1.5 is not an integer, so you find the integer that is the next, that is directly below it, and then f of negative 1 is still an integer, so the output is negative 1. So here our domain is from negative infinity to infinity, because you can plug anything into this function. You can plug in pi, you can plug in 2.5, you can plug in irrational. Any number you can plug in. But the range is going to be different, and we'll see that once we start graphing. So let's graph. So we said that 1 maps to 1, 0 is at 0, but at 1.5 we're still at 1. At negative 1 we're at negative 1, and then if you plugged in 2 you would get 2. So the way that we have, I'm going to zoom in for a second. So the way that we have to draw this is that we know that for all of these values it's still going to be negative 1, and then we have to have an open circle, because if this circle right here, if here was filled in, it wouldn't be a function because there would be two outputs for 0. So the way that we're going to draw this is like this. And it continues on in each direction. So over here, and you can, and it goes on in each direction. And you can sort of test this. So think about 3.5. Is it an integer? No. So that means that our output is going to be different than our input. 3.5, what's the greatest integer that is less than or equal to 3.5? It's 3. So it's going to have the same input as 3. So it's going to be a horizontal line across until you get to 4, which is when you have to jump up. So then you can see our little staircase going up, and you have to just make sure that you're ending with an open circle. So here, our outputs, our range, is not all real numbers. It's all real numbers such that y is an integer. So no matter what you plug into this function, you're always going to get an integer. And that's why you see the step pattern. So if we have g of x is equal to the greatest integer function minus 5, evaluate g of 5. So if we plug in 5, the greatest integer that is less than or equal to 5 is 5. So it's 5 minus 5, which is equal to 0. Plug in 6.5 minus 5. The greatest integer that is less than or equal to 6.5 is 6. Minus 5 is equal to 1. One and 1/3 minus 5, but we have to plug the 1 and 1/3 into the greatest integer function. the greatest integer that is less than or equal to 1 1/3 is 1. So you're going to get negative 4. And negative 1.2. The greatest integer that is less than or equal to negative 1.2 is negative 2. Minus 5 is equal to negative 7. This one might have tricked you up. And let's talk about it. So if you think about a number line, let's plot negative 1.2. So negative 1.2 is about here. So it's past the negative 1. So think about the definition. The greatest integer function asks you, what is the greatest integer less than or equal to x? And so you need to find the greatest integer that is less than negative 1.2. Negative 1 is actually greater than our negative 1.2, so we have to go to negative 2. I know that one might have been tricky, so that's why I wanted to make a note of it. So this is the greatest integer function, and this sort of step pattern where there's a horizontal line and then an open circle is the pattern that you see with step functions. So for a given interval, in this case it's units of 1, the output remains constant, and you end each horizontal line with an open circle to maintain that it is a function. So that is the greatest integer function.